So today we are learning how to simplify expressions, rational expressions. In this problem we are already fully factored, and now we just need to identify which factors in the numerator have the exact same factors as are in the denominator. So we're trying to make fractions of 1, and I see that this entire parenthesis is the same as this entire parenthesis. Both of these parentheses are x plus 3, which means these parentheses together make a giant 1. And if you're able to make a 1, they cancel each other out. So I know this entire parenthesis is going to cancel out with this entire parenthesis. Because this parenthesis was already used with him, he cannot come over here and be used with this guy. This is a 1, he cannot come over here. Nothing else can simplify, so our final fraction is a 4 in the numerator and a x plus 3 in the denominator. That's our final answer, but we have to make sure that this fraction up here is never undefined. So we got to check. We want to know, when will this parenthesis be 0 and when will this parenthesis be 0? Because if either of these parentheses are 0, we now have a 0 in the denominator and we are now undefined, which we cannot have. So we're going to solve for x. I see that they're the same. So this guy is our answer, but we have to say that x cannot be -3, because if x was -3, according to this over here, our fraction is then undefined and we're wrong. So this entire answer right here is actually what you want. This is your simplified fraction, but x cannot be -3. So we're going to practice a little bit more. We have another fully factored rational expression, and we need to identify when the numerator will simplify with the denominator. So I have a couple different colors. I see that this entire 3x is a parenthesis, the same as this entire 3x is a parenthesis. So together, these would make me my fraction of 1. I see that this entire parenthesis x plus 5 matches this entire parenthesis x plus 5, so they would end up making a giant fraction of a 1. I don't see anybody else. Now some of you might be looking at this and wondering, well, they both have x's and they both have a 1 and they're both a minus. Can't I subtract, or can't I simplify them? We're going to look at that one just a little more closely in a minute. So the 3 x's canceled out and the x plus 5's canceled out. So I have the 1 minus x and the x minus 4 in the numerator, and I have a x minus 1 in the denominator. Now, in this binomial, the 1 is written first and the x is written second. Let's rewrite this so that the x is first, kind of like this guy is. So this is a negative x, so I'm rewriting it as a negative x, and that was a positive 1, so here's my positive 1. I am rewriting the binomial so that the variable actually went first. And then I'm going to put in the rest of our fraction. Now these look really close. This is a negative x plus 1, and he is a positive x minus 1. If I factor a negative out of this parenthesis up here, a negative x divided by a negative 1 is an x. A negative 1 divided by the negative 1 is a negative 1. So I factored out a negative 1 from here. He is x minus 4. Our denominator was always the x minus 1. I was able to factor out, and now they actually are the same. I have proven it. So this is a fraction of a 1, which means these two guys cancel each other out, which means I have nothing else in the denominator anymore. My answer is a -1 times the x minus 4, which some people would rather you simplify as negative x minus 4. Now remember, we need to look at the times when this original denominator was undefined. Because there are 3 parentheses, we have to test all 3, because all 3 are going to be answers. So solving for x. So negative parenthesis x minus 4 is our simplified, but these 3 cannot exist. X cannot be 1, x cannot be -5, and x cannot be 0. This is our full and final answer. So now let's look at a rational expression that is not factored yet. Please do not cross off this x squared and this x squared. They are not the same full parenthesis. It has to be the same full parenthesis for you to be able to make it a 1. Please do not just cross these off. So we need to see if the factor on the top has any factors on the bottom. So we need to factor it. I can see that both of these had an x in common, so I'm going to factor out an x. I'm looking for GCFs. I don't see any numbers in common, so I'm only factoring out the x. If I factor an x out of x squared, I get an x. Divide this by an x, I get a 7. So I factored this by finding a GCF of an x. If you were to multiply this back through, you would get this numerator. Prime factorizing x squared is x times x. I can now see that I do have a fraction of a 1. This whole parenthesis x and this whole parenthesis x actually simplify each other out. They cancel each other out. So I'm left with the x plus 7 in the numerator and an x in the denominator. Again, please do not cross these x's off. This is not a whole parenthesis, and this is not a whole parenthesis. You cannot just cross them out. This is connected by an add. We are adding. Now, we got to check our undefines. This denominator cannot be 0. If it's 0, then we just made a whole mess. So I got to figure out what this would be. Take the square root of both sides. Then x is going to be the square root of 0 is just 0. So this is our answer, but remember, x cannot be 0. So our last problem for today, we have a rational expression that we need to factor. You always look for GCFs first. I do not have a GCF in the top, in the numerator, and I do not have a GCF in the denominator. So now I just need to see, so looking at the numerator by itself, it's a trinomial, which means I need to figure out what a times c will actually add up to be. So a times c is a negative 12. Somebody better multiply to give me a negative 12, but needs to add to give me a negative 4. So two numbers that multiply to give me negative 12, but add to give me negative 4. If you have a hard time finding them, just start at negative 1 and come up with all the possibilities to get you negative 12. So there's my 1s, and then I can try my 2s. You only need to do this if you really cannot remember, or if you just can't find it. So I tried my 1s, my 2s, my 3s. If I did 4s, I'd be repeating. So these are all the different ways to get negative 12. Only one of these, if you were to add them together, would get you negative 4. So if I look at all of them, this one right here is the only one where if I added these two numbers together, I would get negative 4. So I'm going to use the numbers 2 and negative 6. So factoring the numerator, I have x plus 2 and I have x minus 6. I just factored my numerator. Now I need to go and I need to factor my denominator. This is a difference of squares. So I know that this has to be x plus 2 and this has to be x minus 2. Now looking at it, I can see now that this entire parenthesis x plus 2 can make a 1 and they actually cancel each other out. So what I have left is the x minus 6 in the numerator and the x minus 2 in the denominator. Do not cross these x's out. It had to have been a full parenthesis for you to be able to cancel it out. Well, now we have to go back and we have to look at undefined. When is this denominator actually equal to 0? So we need to add the 4 and take square root of both sides. So x is going to be, square root of 4 is plus or minus 2. So this is your answer, except for x cannot be a positive or a negative 2. This is our full and final answer. I want to add a little side note. I actually had somebody ask me to review difference of squares, so I want to put this here real fast as a review. If you can take the square root of the front, and if you can take the square root of the back, and if it is a subtraction problem, it's a difference of squares. So the square root of the front, the square root of x squared was x. The square root of 4 was 2. And because it's a subtraction problem, then we know we can immediately throw it in. So fronts are x's, backs are 2's. The rule for difference of squares is that it goes plus minus. That's how I got this guy right over here.